Once again, just I'm refreshing it. Why the control of production line is very important. See, there will be a lot of sequential operations will be happening, and so many aspects like safety aspects have to be taken into account, and the whole integrated production line have to be controlled in a different fashion. So for this is become very important. So under this, we have two important components and the controllers. So control functions I had discussed in the earlier class. The control functions are basically sequential controllers, safety monitoring, and quality control. The sequential controls are those will be controlling the activities, what activity have to be done first and what activity have to be carried out next. These will be by means of logical or sequential controllers. Okay, these are also called as logical controls or sequential controls. And the time of operation, everything will be maintained, and in time the program will be feeding the informations, and sequentially the operations will be done in a proper way. In some of the cases, the system itself will be deciding the optimized machining operations or optimized processing operations. Okay, those are high level programming languages. Those will be used because the machining hours or the manufacturing hours, each and every 1 minute is very, very important in the manufacturing. Okay, so that time, if the complicated operations have to be done, that means the operations will be simple. Sometimes the design will be complicated. So that time, what operation have to be done first and what operation have to be done next, that will become a question mark. So that time, some of the softwares will be using, and those will be giving you the optimized path by which we can go for the processing. And safety monitoring, already I think the second time, the safety monitoring is the safety to the workers, safety to the systems, safety to the surroundings. So for this, primary level of sensors, secondary level of sensors, tertiary level of sensors will be provided in and around the work volume of the machine or a robot. Okay, so the sensor which are fixed on the body of the machine or a robot, which will be protecting itself. The second one, within the work volume of the machine or a robot, if any intervention is there, a human intervention or any part is falling, then a feedback path through this, a sensor will be identifying the signals and sent to the systems so that it will be stopping the processing or further operation. Just like a driver is riding the vehicle on the road, a buffalo is crossing the road. So that time the driver will be taking two important decisions. One decision is that suppose he is going at a 60 kilometers per hour, he'll slow and he'll go at slow rate. He'll not stop. He'll go at slow rate until the intervention is cleared from the road. Or the second one, he'll stop the vehicle for some time until the path is cleared. So like this, the program, the well-built the logics will be provided. So those will be in connection with the, or they will be having a feedback will be taken from the sensors, and they'll be safeguarding the work volume. The third one is very cautious, very, very important surrounding within which no one should not be entered. For example, 440 volts, no one should not enter. Or some very dangerous space with nobody should not enter. So there, some kind of sensory pads will be, mats will be provided, and any intervention is there, those mats will be having series of sensor connections, and those will be giving the feedback to the controllers so that the decisions will be taken. So the three important things already I told: control functions under this sequential control, safety monitoring, quality control, okay, and safety monitoring. And the quality control is what? Then the quality control is, it is very, very important thing. Controlling, say, all these have been provided only to get into globalization. Globalization is that the design or a manufacturing, whatever you are going to do, globally it should be standardized. So that time a high quality expectation will be there from the customers or the consumers. So here what we are going to do is that we are going to have control over the quality of the systems. So how the quality of the systems will be controlled? So one thing is well-built systems will be provided just like in CNC machines. What they do, they will be measuring the quality of the product, and inbuilt sensors or inbuilt inspection systems, those will be inspecting and recovering the mistakes, modifying the mistakes, so that there will not be any rejections at all. And in a highly automated industry, in between automated system, if a manual intrusion is there for the testing, what happens? There will be blocking of station or and starving of station happens, and entire system will be blocked. So in such situation, some kind of the automated devices, automated systems, those will be inspecting the systems, and those will be used so that the 100% thorough inspections can be done, and all the desired quality characters will be thoroughly inspected, so that there will not be much more any problems with the system. That will be a quality control function. The next important thing which I have to discuss is the line controls. The line controllers are what? As the name indicate, line. Line is a flow line. The flow line is what? The flow line is entering of the raw material, a conveyor, appenders, downenders, robots, and the machines. That means the workstations, work centers, all these will be integrated together, and they will be performing the work in integration. So how these functions will be done? How the material will be moved from one station to other station? How the work will be completed? Then how there will be integration between the two systems, the machine to machines, machine to robot, machine to the conveyors, conveyor to the machines. All these will be well built feedback systems they'll be having, and this will be controlled by PLCs, programmable logical controllers. So in fact, I wanted to go for the the student development program. It is costing you around 500 rupees. Already I had a discussion, and this PLC, what you can do is you can earn the money by keeping a mobile. In the mobile you can have you can download the PLC, the programmable logical controller ladder logic, and whatever the industries or some automations they required, you can logically create the program and we can sell them. That also you can do it once you attend this program. Let us see how effectively we can do that. Okay, here I am talking about a PLC. A PLC is a programmable logical controller, and here we are going to create the ladder logic diagrams. The ladder logic diagrams are those how sequentially the operations are required. Those can be created, and these ladder logic will be played, and entire industry will be working based on this ladder logic. And if any suitable changes or any changes have to be done, or you want to change over one program to the other program, just like you are going to open the window, Excel window, you are going to open the Words window in your laptop PCs, many times different files. In the similar fashion, we can change over the PLC ladder logic programs already, those have been stored in the PCs. Okay, this is one advantage of going for the PLCs in the line controllers. And what are the benefits of going for these line controllers? I took the suitable example of programmable logical controllers and so many others. And today we were talking about the industry 4.0, and here the internet connected PLCs, the programmable logical controllers can be used. For example, the industry is working in Australia. I can do the programming from here. I can look into how the processing will be happening and how the informations are flowing. Where is the breakdown? How much time it has taken? All the informations we can collect through the internet, and we can verify and we can test, and even we can do the changes in the program. That is one of the benefit by using these methods. Okay, and what are the benefits of going for the computer controlled the programs? That is opportunity to improve and upgrade the control softwares. So that means we can upgrade the softwares, and we can change some anticipated problems can be solved with the original systems, and we can even do the diagnosis also can be done, and we can we can create the program just like a dry test we do in the computer machining. That means without putting the material, we are going to do the testing of the program which I have already created, because directly if you are going to use it on the material, what happens, the material will be very costlier in the CNC machines, the raw material will be. And if a small mistake is there, that will be reflected on the original material. It will be totally a disposal. It is a waste. So that we are going to do testing on the wax or the wood, or even dry testing. That also can be reduced. Just we can create the model in the computer itself. Virtually we can do the machining, or we can do the activities in the computer itself. Any changes or verifications can be done. Those can be done. That is one opportunity to improve and upgrade the control softwares and record the data on processing performance. So it is mainly required for the customers and required for the manufacturing authorities, and required at the managerial level, and even the legal reasons also it will be required. And whatever the data, that means the data processing operations, and how many parts have been taken, and how many parts have been lost, and how much time it has been taken to diagnose, all these informations which are it are essentially required at the managerial level. Those data can be retrieved from the system. That is one of the advantages of going for the computer control. And diagnostic routine to expedite the maintenance and repair. So the expected amount of time it has been taken, and which station has come for the maintenance, what was the expected reason, on how much time it has been taken. All the informations can be stored even years together. We can retrieve the information. That is the diagnostic routines to expedite maintenance and repair. And the next one, generation of preventive maintenance schedule. Generation of preventive maintenance schedule. What is the preventive maintenance? So the preventive maintenance is one, whenever it has come for the maintenance, we are going for the maintenance. It is not. Whenever on the road your vehicle has come for the maintenance, the engine is not working, suddenly stop, it is not preventive maintenance. The preventive maintenance is that we are going to do the diagnosis before it come for the maintenance. Suppose I want to go to the Majestic, I am not going to check the engine oil. I want to go for a tour of 600 kilometers. I am going to do the testing of the engine oil, whether it is there or not level. So all these preventive maintenance we are going to do with the vehicle in the similar way. The list of preventive maintenance will be provided by the system itself, and we can do timely, we can do the maintenance. That is a preventive maintenance. It is not a breakdown. Okay, so it is giving you the list. So this particular day, today it is a timetable of maintenance. It will be given, and it reduces, so that it reduces the downtime. Because once it has come unexpectedly, if it has come for the maintenance, then it is a loss of working time. So before that, we are going to take the prevention by using the data of the computer. So that is generation